everyone. Welcome to episode number 675 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Did you miss me? Why, yes, last week, for a variety of reasons, this here fish fry didn't quite make it out of the pan. But this week, I'm back with the one and only Rob Knoth from Cadence Design Systems. Rob and I are investigating a major shift in electronic design automation, the integration of artificial intelligence right into the design flow. That's right, my friends. We are talking all about Cadence's newest innovation, the ChipStack AI Super Agent. We chat about Cadence's overarching design for AI and AI for design strategies. Discuss the core challenges facing verification engineers today, and look into how ChipStack AI Super Agent aims to be an orchestrated virtual silicon organization that brings predictability and acceleration to the most risky parts of the design process. So, without further ado, please welcome Rob to Fish Fry. Hi, Rob. Thank you so much for joining me.
Hey, Amelia, thanks for having me. It's always great to be back on the fish fry.
Excellent. All right. So, Rob, we're talking about Cadence's new ChipStack AI Super Agent today. But first, talk to me about Cadence's design for AI and AI for design strategies.
Happy to talk about that, Amelia. It's exciting. It's a great time. It's core to who we are, and it's important also because I think, it's impossible for anyone to pick up a newspaper or read a newsletter without having something to do with AI. But really, those of us involved in the semiconductor and system design industry play a unique role, right, in creating that and making it even bigger. And so, what is design for AI and AI for design? This is really the way that Cadence looks at our role in this overall journey that humanity's on. So, the first half of it, design for AI, this is all about like kind of the work we've done for decades now, which is partnering with the leaders in the industry who are actively involved in creating the chips and data centers and devices that are creating the next generation of AI or delivering that as a user experience to you, on your devices. But then it's more than that. The other half of it is also AI for design. Once those models are created, once you've got this ability to have AI, it's more than just something to write funny poems or help you research restaurant recommendations. It has a unique and powerful role in engineering itself. And so this AI for design is all about at Cadence how we are applying AI into our design solutions and getting them in the hands of the people that are creating that next generation of infrastructure. And so it's a virtuous circle. You design for AI to create the AI, that makes your tools better. Those better tools are then used to create the next generation. And we keep going.
Absolutely. Okay, so ChipStack AI Super Agent is aimed specifically at front end silicon design and verification. So, what are the biggest challenges you're seeing in front end silicon design and verification these days?
So verification and design are a unique corner of the overall semiconductor design process. And if you think about what has EDA been able to address the most over its history, well, it really in the late 90s, early 2000s, EDA was really aimed at solving a lot of the challenges in the physical design space, right? In the back end design, implementation, the layout, the cell placement, routing, optimization, buffering, all those problems, right? Because especially when we were entering the FinFET era, that physical implementation was incredibly difficult, incredibly challenging, lots of physics involved. And so automation was a great way to kind of help accelerate and empower design. Well, once you start making that part easier and you can actually build more complex things easier. Then the next challenge comes into creating those new, more complex systems and verifying that they're actually going to work. So that's really has now, and for the past many years, been the long tent pole in design challenge is that verification is never a fully solved problem. For modern semiconductors, you verify as much as you can, as exhaustively as you can with as much compute resources and humans as you can put on the problem, but you got to take that chip out, right? So you get as close to 100% as possible with the resources you have. So the other kind of interesting thing about verification is the fact that there's a whole lot of natural language involved in it. If you start thinking about, I have a specification that is written in natural language, and I'm now creating test benches, I'm creating RTL, I'm creating tests, I'm verifying tests, doing formal verification, et cetera, et cetera. There's a wealth of areas here where natural language is involved. And so it made it a really great fit for this because one, it's a very important problem to solve to ensure that the pace of innovation can keep going, that the designs work right the first time. It's something where it has natural language, so the synergy with large language model type technology is right there. And it's a domain where it requires deep technical expertise to do really well. And so it's a fantastic area to apply AI to solve those problems, to help bootstrap and educate and empower the next generation of engineers to learn these techniques. Because honestly, the complexity and scale and growth of the designs is far outstripping the new engineers that are coming out of schools, to work on them. And so it's a great area to apply, especially agentic AI. And we really founded this solution on is a unique marriage between large language models and all of the inherently stochastic AI processes with core EDA technology and the two reinforcing each other to ensure that you can trust it, that it's not hallucinating, and that it's producing higher quality outputs.
All right. So walk me through the details of the solution. It utilizes all of Cadence's foundational EDA tools, right?
That's correct. It is heavily based, like I mentioned, on the tools themselves and the AI. So, really, if we walk you through kind of what's happening here, and this is no stranger to the people who are doing verification and design creation, you start with a wealth of multimodal inputs. It could be design documentation, it could be Verilog from a previous generation project, it could be screenshots of block diagrams or pictures of whiteboards, et cetera. You take all of that information together and we feed that into this super agent. And that name super agent is intentional, right? That's an orchestrator agent. It's not an agent with a cape on flying around. I mean, maybe it could be, but it's really there to orchestrate a wealth of different agents that are essentially a virtual silicon organization that every verification engineer has at their fingertips. And so we're going to take that large amount of design intent, bring it in, use a combination of large language models and first principles grounded core EDA technology to interpret, enhance, elaborate, and add reasoning and context and relationships to create this structured understanding of the design intent, something we call a mental model. Now, what that is, it becomes a single source of truth for the design that all aspects can refer back to. And so that way, as someone is planning a verification strategy, or they're debugging test failure results, or they're looking to make incremental updates to the RTL, you're all referring back to that same mental model. And this is great because if you think about how an AI works, right? Like it's probabilistic. It's trying to come up with what is the most likely right answer. If it has to just rely on probability 100%, that's where hallucinations come in. By giving the AI access to a structured understanding of the design intent, the chance of hallucinations go way down. If you're asking it a question about a port list and it's got to try to sort through all those PDFs it's digested, how do you know if it's going to come up with the right answer? Whereas if the AI has access to this mental model, it has a hierarchical, structured understanding of the design information, it immediately returns the ports. And so it makes it more trustworthy. And the less time it spends thinking about what the answer actually is, the more time it can spend on giving you higher quality results. And so it's a win-win. So once we have that design understanding in the mental model, then there's a host of different agents that the super agent can orchestrate. And those are those things I talked about where you could be generating incremental RTL, you could be creating new tests, you could be debugging tests. And what's wonderful about this sort of an approach is that it dramatically accelerates the ability for a verification engineer to get their work done. It also represents a way for an architect who isn't a verification engineer to be doing unit tests, to be, verifying that the RTL they're creating is actually going to work. It's doing what they said. And so again, it's shortening what that project time schedule is. It's improving the confidence of getting things done. And it's doing it in a way that's very resource efficient.
So, Rob, flexibility is also a critical component of this solution as well, right? So, it also supports different cloud-based models and open AI models. Is that right?
Yeah, that's correct, Amelia. And flexibility and security are no strangers to EDA, right? No two different design teams' flows are ever identical. And so the EDA industry for generations, we've had to grapple with the fact that you're going to produce a tool, but that tool, how it's used in practice by the different design teams, is never going to be 100% identical. And so applying agentic AI to this, there's no reason that that should change either. And so it's very flexible in terms of the individual work models people have, but it's also, you are correct, flexible in terms of the LLMs that it's accessing. There are customers, who are using their own proprietary models, and so we can plug those in. There are customers that are going to be using off-the-shelf, state-of-the-art frontier models, right, that are cloud hosted. And we also work with those as well. What's fascinating, and there's a paper published on this, if you look at the amount of content that a standard state-of-the-art large language model is trained on, HDL, so hardware description language, is less than 0.1% of that model. That's roughly equivalent to the amount of Fortran code that it's trained on. And so if you're just going to take an off-the-shelf frontier model and start trying to do semiconductor design and verification with it, that's a little difficult. And this is where taking the model, marrying it with EDA tools, being able to help them help each other produces much better value. Now, one other research area that we've been looking at Cadence and with some of our partners is actually taking some of those models and doing additional fine tuning based on our own proprietary data that we have. And it's amazing to see how much that accelerates the quality of results that's available. So stay tuned. It's an awesome, fast evolving space that, there's still a lot of opportunity available.
I love it. All right. So, Rob, what do you think are the biggest benefits of ChipStack AI Super Agent?
So I'd say that the benefits that we really see is the fact that one, again, like we mentioned in the beginning with verification is one of the longest poles in the schedule and the one that is most risky at preventing, the chip from needing a spin. And so big benefit here is the fact that you can bring in the schedules of verification. You can improve the efficacy of your resources that you're devoting to it, the amount of simulations you have to run, et cetera. So that's a really big one, right? It improves the quality and then time that's devoted to verification. The other big one there is like what I hinted at, which is that, and I feel kind of corny to use the phrase left shift of verification. The more that we're empowering non-expert users to do high quality verification early, that's just better for everybody, right? And so allowing the people who are architects or the people who are writing some of the Verilog to do this work, that's another major one. And I'd say the third one, and this is a cousin to that one, is really when we start thinking about the engineering pipeline, the next generation of those design architects, the next generation of expert verification engineers. Having a effective agentic AI solution to allow junior engineers to do work is a huge goodness for them to learn the ropes. And if you're able to do more chips in a shorter amount of time, that is the best way for junior engineers to learn. If it takes you 2 years to do a chip, there's only so many iterations that junior engineer can experience. If you can accelerate that timeline, the more iterations a junior engineer goes through, the quicker they become a senior engineer. And we really see agentic AI as a key element of that.
That is fantastic, Rob. Absolutely. All right, before I let you go, let's talk about a fish fry. So, we have a similar background when it comes to the Midwest. And we were talking before the call about the differences between a fish fry and a Midwestern fish fry. So, talk to me about that.
Yeah, it's fish fries are near and dear to my heart. I was born and raised in Wisconsin, went to school at Purdue in Indiana, and when I'll go to a restaurant and my made my wife promise me this, and she always reminds me when we're not in the Midwest and I see fish and chips on the menu, and I really want to have I think about ordering, and she's like, "It's not a fish fry." And so, yes, they are both fish that are breaded and dipped in oil and battered and fried up, and that's great, and that's better than nothing. But there's something unique. A Wisconsin fish fry, there's love in it, there's heart and soul that is, you can't just clone a recipe. And so it's really about, coming together on a regular basis. Friday, going down to the bowling alley, and it's a community feel. And yeah, the rye bread is tasty and the coleslaw is fantastic, and that perch and walleye is second to none. But it's really about, that community and that love, and that's the fish fry.
I love it. Yes, indeed. Well, Rob, it is always a pleasure having you on. Thank you so much for joining me.
Thanks, Amelia. Looking forward to the next time.
Well, folks, that's all I've got for this week's Fish Fry. If you'd like more information about this topic, check out this week's Fish Frying page on eejournal.com or this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn, and we are also on Blue Sky Social and Mastodon too. And we have that YouTube channel I just mentioned, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of April 3rd, 2026, I'm Amelia Dalton, and you've been fried.